My dear student, in the previous video, we have solved some problems in the exercise 7.1 under the topic applications of differential calculus. Now in this video also, I am going to continue the same exercise. Problems in the exercise applications of differential calculus, chapter 7. In the second problem, we have given that a camera has been accidentally fall down from the cliff of 400 feet height. The camera falls a distance of s equal to 16 t square. This is the second problem. It is the cliff. Here a camera is there. It is of height 400 meter. Here is a camera. It reaches the ground after 5 seconds. And they ask you to find out how long does the camera falls before it hits the ground. The camera hits the ground, it travels 5 seconds. That's the first question. And the second one is, what is the average velocity which the camera falls during last 2 seconds? That's also I have determined. See, this is 2 seconds, this is traveling 3 seconds. After 2 seconds, what is the average velocity they are asking? Since that it is falling from the top, its equation is given by minus 16 t square. The direction indicates negative sign, indicates the direction. When it falls from the cliff, after 5 seconds it reaches the ground. What is the average velocity? In the last 2 seconds they are asking. So average velocity is S5 minus S3 divided by 5 minus 3, that is Newton quotient. Since it is a negative, falling from the top, direction is negative, so we can write it as minus 16 into 5 square minus of minus 16 into 3 square divided by 5 minus 3 is 2. So this is 25, this is minus 400, this is minus to minus plus 144 by 2. So this is equal to 256, minus 256 by 2. See, we can indicate negative sign also. So in the previous video, I haven't given the negative sign. Just I gave the taken into account as magnitude only. The velocity, the absolute velocity, you need not take the sign. If it is indicates the direction, you have to mention the sign also. So this is equal to minus 128. What is that? Distance is feet. 128 feet per second. You can indicate the sign is also. Without sign, you can observe, if you write it as 128, it is absolute velocity. So sign indicates the dropping of the camera. So next, one more question in the problem. What is the instantaneous velocity of the camera when it hits the ground? What is the instantaneous velocity of the camera when it hits the ground? Instantaneous velocity when it hits the ground, it travels 5 seconds. So, instantaneous velocity, that question. So this is 3 seconds, and after 2 seconds we have determined the average velocity. Next, we have to instantaneous velocity. instantaneous velocity is ds by dt. Instantaneous velocity is ds by dt. That is equal to differentiation of s with respect t square is 2t, so minus 32t. T square derivative 2t, 2 into 16 minus 32t. So what is the instantaneous velocity when it reaches the ground? It travels 5 seconds. So instantaneous velocity at t equal to 5, that is ds by dt is equal to v of 5, I think. Velocity. This is v of t actually. This is v of t. So minus 32 into t is 5, that is equal to minus 150 feet per second. This is the third subdivision of the problem. So the camera reaches the ground when it travels minus 1, velocity when it reaches the ground is minus 150 feet per second. That is the third question. What is the instantaneous velocity of the camera when it reaches the ground? The instantaneous velocity of the camera when it reaches the ground is minus 150 feet per second. That's all about the problem 2. Next, problem 3 is exercise. Exercise problem number 3. A particle moves along a line according to the law. A particle moves along a line according to the law. A particle moving along the line whose equation of motion, the law is s of t equal to 2t cube minus 9t square, 2t cube minus 9t square plus 12t minus 4. So 2t cube minus 9t square plus 12t minus 4 is the equation of motion of the particle where t is greater than or equal to 0, where t is positive, greater than or equal to 0. And at what time the particle changes direction? First question is, at what time the particle changes its direction? The particle changes its direction when the velocity is 0. When the velocity is 0, the particle changes its direction. When the velocity is 0, the particle changes its direction. Changes its direction when the velocity is 0. What is velocity of the particle? V of t is ds by dt. That is equal to differentiation of the s function with respect to t. 3t cube is 3t square. So 3 2s are 6t square. T cube is 3t square. 3 into 2, 6t square. Derivative of t square is 2t. 2 into 9, 18t. 2 9s are 18t. Plus 12 into derivative of t is 1. Therefore 12 into 1. 12 minus 4 is a constant, derivative is 0. This is the velocity of the particle. Since v of t equal to 0 implies 6t square minus 18t plus 12 equal to 0. So the particle changes its direction when the velocity is 0. So after finding the velocity, we equate it to 0. Velocity is 6t square minus 18t plus 12 equal to 0. Taking 6 as common term, you get t square minus 3t plus 2 equal to 0. T square minus 3t plus 2 equal to 0. Factorizing this, 6 into t minus 1 into t minus 2 equal to 0. 6 not equal to 0. Therefore, t minus 1 equal to 0 implies t equal to 1. T minus 2 equal to 0 implies t equal to 2. So, the particle changes its direction at t equal to 1 and t equal to 2. The particle changes its direction at t equal to 1 and at t equal to 2. That's the first question. What is it? First question is, at what time the particle changes its direction? At time t equal to 1 seconds and t equal to 2, the particle changes its direction. So the answer for the first question is, the particle changes its direction. The particle changes its direction when t equal to 1 and at t equal to 2. This is the answer for the first subdivision. When the particle changes its direction when t equal to 1 and t equal to 2. Next subdivision is, find the total distance travelled by the particle in the first 4 seconds. Total distance travelled by the particle in the first 4 seconds. Next question is, second subdivision, the total distance travelled by the particle the total distance travelled by the particle in the first 4 seconds. And that is the second question. First 4 seconds is modulus of s of 0 minus s of 1 because t equal to 1 plus modulus of s of 1 minus s of 2 plus modulus of s of 2 minus s of 4. So total distance travelled by the particle in the first 4 seconds is 0 to 1, 1 to 2, 2 to 4. S0 minus S1. Actually, what is S? S is given as 2t cube minus 9t square plus 12t minus 4. This is your S. S of 0. In the place of S, you substitute t equal to 0, 0, 0, 0, you get only minus 4. This is minus 4. S of 0 is minus 4. If you put t equal to 0, 0, 0, 0, only you get minus 4. Minus S of 1. In the place of t, you substitute 1. S of 1 is 2 into 1, 2. 9 into 1, minus 9. 12 into 1 plus 12 minus 4. So 12 plus 2, 14 minus 13 is 1. Minus 9 minus 4 is minus 13 plus 14 minus 13 is 1. Plus S of 1. S of 1 you know 1. Minus S of 2 you want. In the place of t you put 2. 2 cube is 8. 8 2s are 16. Minus 2 square is 4. 4 9s are 36. 2 cube 8, 8 into 16, 2 square 4, 4 9s are 36. T equal to 2, 2 12s are 24, plus 24 minus 4. Here also 36 minus 4 is minus 40. 16 plus 24, 40. This is 40 minus 40, therefore 0. S2 is 0. So S of 0 minus 4, S of 1, 1. Similarly, plus S of 1, 1, S of 2 is 0. Similarly, the next case, S of 2, you get 0. Minus you want S of 4. Now, you want S4. For that again, S of 4 is, in the place of T, you substitute 4. 2 cube, 4 cube. 4 cube is 2 into 4 cube minus 9 into 4 square plus 12 into 4 minus 4. This is S4. 4 cube is 64. 64 into 2, 128. 4 square is 16. 16 nines are 144 plus 12 fours are 48 minus 4. So 128 plus 48, 176 minus 144 plus minus 4 is 144 minus 4 minus 148. Subtracting, you will get, what do you get? 176 minus 148, 8, 16 minus 8, 8. 6 minus 4, 2. $128. So S4 is 28. Okay. See, S of 0 minus S of 1 plus S of 1 minus S of 2 plus S of 2 minus S of 4 is 28. The answer is minus 5. Modulus of minus 5 is 5. 5 minus 4 minus 1, 5. Modulus of 5 is 5. Plus 1 minus 0 is 1. Plus 28. Answer is 34. This is, what is that? 1 plus 28. That is equal to 34. So the total distance travelled by the particle in first 4 seconds is 34. What is it in meter? What is the measurement given? Units only. 34 meters or feet, whatever it may be. This is the total distance travelled by the particle in the first 4 seconds. And the third one is also there. One more result in the problem. One more question in the problem. Find the particle's acceleration each time the velocity is 0. Each time the velocity is 0, find out the acceleration. Acceleration is, velocity is 0 when t equal to 1 and t equal to 2. You know, velocity is 0 when t equal to 1 and t equal to 2. Therefore, you have to find out the acceleration at when t equal to 1 and t equal to 2. This is the total distance travelled by the particle in the first 4 seconds is 34 units. Next, third one is third problem. Third problem. Find the particle's acceleration each time the velocity is 0. Particle's acceleration 0. Velocity is 0 when t equal to 1. Velocity is 0 at t equal to 1 and at t equal to 2. At t equal to 1, t equal to 2, the velocity is 0. Therefore, acceleration is dv by dt. V, you know, velocity is here. What is the velocity? 6t square minus 18t plus 12. So dv by dt is 6t square. T square is 2. 2t, 2 into 6, 12t minus 18, the derivative of t is 1. 12t minus 18 is the velocity acceleration. Velocity is 6t square minus 18t plus 12. On differentiating velocity with respect to t, 12t minus 18, constant 12 is 0. Derivative of constant 12 is 0. So velocity at acceleration at t equal to 1 we want. When velocity is 0, we want dv by dt at t equal to 1 is equal to 12 into 1 minus 18, that is equal to 12 minus 18, that is equal to minus 6 meter per second. Similarly, velocity, acceleration at t equal to 2. At t equal to 2, the velocity is 0. So at t equal to 2, acceleration is 12 into 2 minus 18, that's equal to 12 2s are 24 minus 18, that is equal to 24 minus 18 is 6 meter per second. So each time the velocity is 0, acceleration is minus 6 meter per second and meter per second square. Acceleration is meter per second square. Velocity is meter per second. Acceleration is meter per second square. That's all about the acceleration. About problem 3 is over. Problem 3 is over. Okay. Next, one more example I am going to solve now. Example number 7.5 in the textbook. So you will see the example now. Textbook example 7.5. Example 7.5. A particle is fired straight up from the ground to reach the height of s feet in t seconds. A particle fired from the ground, it fired up from the ground to reach height s feet in t seconds. Height is s feet in t seconds, where s is equal to s feet in t seconds. S is 128 t minus 16 t square. This is the height of the particle. When it is fired from the ground, it reaches s distance at t seconds. Compute the maximum height of the particle reached. First problem is maximum height reached. Maximum height reached by the particle. Maximum height reached by the particle when what is that? Maximum height reached the particle when, what is that? Velocity is 0. Here, velocity is 0. When maximum height reaches, velocity is 0. When velocity is 0, the maximum height reaches by the particle when velocity is 0. What is velocity? V of t equal to ds by dt equal to 128 into the derivative of t is 1 minus t square is 2t, 2 into 6, 16, 32t. 32t. This is velocity, meter per second. Feet, it is given in feet, the feet per second. Okay, this is when this is 0. Maximum height reached when t is 0. Velocity is 0 implies 128 minus 32t equal to 0. 128 minus 32t equal to 0, that is 32t equal to 128. So t equal to 128 by 32, that is equal to 4 seconds. So after 4 seconds, the particle reaches the maximum height. It reaches the maximum height after 4 seconds. What is the maximum height? Substitute t equal to 4 in S. The maximum height is at t equal to 4, S of 4 equal to 128 into 4 minus 16 into 4 square. What is 128 into 4? (512). 128 into 4 is 512 minus 4 square is 16, 256. So 512 minus 256 is 256 meters. This is the maximum height reached by the particle is 256 meters. That is the first subdivision. 256 feet, sorry. See, feet is given, problem as it is given as feet. Therefore, this is feet. Next subdivision in the problem. What is the velocity when the particle hits the ground? When the particle hits the ground, distance is 0. When the particle hits the ground, distance is 0. Second subdivision is, what is the velocity when the particle hits the ground? When the particle hits the ground, S is 0. Second subdivision, when the particle hits the ground, distance S equal to 0. So 128t minus 16t square equal to 0. You can take 16t as common. 8 minus t is 0. 16 not equal to 0, therefore t equal to 0 or t equal to 8. So t equal to 0 is not possible. T equal to 8. At t equal to 8, the particle hits the ground. The particle hits the ground. The particle hits the ground at t equal to 4. T equal to 0 is not possible. So you consider t equal to 8. This is the time when it reaches the ground. And what is the velocity when it hits the ground? The velocity when it hits the ground. The particle hits the ground. The velocity is, what is velocity? Velocity is 128 minus t square is 2, 32t. So our time in t equal to 8, 128 minus 32 into 8. That is 128 minus 256. That is equal to minus 128 feet per second. So at minus 128 feet per second is the velocity when the particle hits the ground. The velocity when the particle hits the ground is minus 128 feet per second. That's all about the example. And I will stop the video here, and we will continue the exercise in the next video. Thank you.